Hi, and welcome to the HANA Academy. My name's Philip, and in this video tutorial series, we're showing you how to build an end-to-end solution in HANA 2.0 based on a live Twitter feed. In this video, we're going to continue setting up the predictive clustering and segmentation of our project. Now, in the previous video, if you remember, what we did was we created the table types and tables that we need. For doing that, we used a CDS entry, so here. And then we also created our stored procedure using the HDB AFL lang procedure entry, so which would actually call our k-means using those table types. So we've set up our stored procedure. Before we can run it, we need to actually populate our parameter table, the input data we've got in a view, but the parameter table needs to have some values in it. So rather than us going off into SQL and or importing a table in a traditional way, we're going to see how we can quite succinctly do that directly in our project. And what this means is we have the advantage of, if we populate the table at least with the default settings, the default rows, it means that when we deploy this project to production, we don't have to do any running of SQL. It'll all be happened as the project is deployed using the XS advanced architecture. So what we're going to need to do is to actually get some data, for example, in CSV format, and then set up something called an HDB table data entry that will define to read from that CSV entry and put the rows into the table that we created in our CDS entry. So we've got the code for that. If we go back to GitHub, you know where this is by now. In DB SRC of Live5 project, we've got palparams.csv. So you can see here we've got a CSV entry with some values that, of course, you're going to find these and reference these when you're in the documentation. If you remember, we saw in the last video here group number min, max, for example, the settings are here. Now, in our case, what we want to do is to have between 5 and 10 clusters created or groupings. So we've specified minimum 5, maximum of 10. And there are some other parameters that are maybe a little bit less relevant. If you've got lots of threads, you can make use of them by using the thread number parameter. There are some initialization parameters, how many iterations, how long it should actually go around doing the algorithm in memory in HANA to actually calculate the clusters, because you could have it running for a long time or a short time. So 100 iterations is a good starting point. And you can also set an exit threshold for when it thinks the clustering is good enough that it can actually quit the calculation process. So again, it's a very data intensive, very good for doing natively inside the HANA engine, which is what's happening in memory when we use the predictive analysis library. So we've got integer and double values. In this case, no string ones were needed. So this is what we want to basically get populated into a table, because the PAL is always table based. So for that, we can go to raw, and there we can see that's actually the CSV values. Of course, if you've got a CSV, you could just go ahead and just do the file import option and actually import from your local file system. But as we've got it in GitHub, I'm just going to copy and paste it in. So let's go ahead and create a new entry. And I'm going to call that file palparams.csv. So palparams.csv, respecting the case. And I'm going to paste in those values and save it. So that's just basically set up this CSV entry. What we now need to do is specify how this data should be loaded into a table. And for that, we're going to create another thing, this HDB table data. So let's go ahead and create it. So a new file, we'll call it palparams, why not? It's the same thing, .hdb table data. And in here, we're going to need to specify some JSON that defines how to get from the CSV into the output table. And of course, you don't have to write it from scratch. We've already got it for you on GitHub. So go to palparams HDB table data. And there we'll see we've got some JSON. I recommend, if you want to copy and paste this, it's probably easier in this case not to use raw, just to use it as is, because it's formatted JSON. And we'll paste that in. And let's have a quick review. What we can see is that we've specified format version 1. We're going to import to a target table, which is in our PAL context params. That's the table we set up in our CDS in the previous video. It's a CSV type. We want the actual CSV to be used. Again, is the palparams.csv. That's what we just set up a few moments ago. It's got a header in there. Let's just check. Yep, it's got a header row with the column names in double quotes. The delimiter is a comma. Yep, let's just double check. Yep, delimiter in there is a comma. Of course, you can have different formats, and it's got quotes in there. And then we're basically going to import these 4 columns: name, int args, double args, and string args, all 4 columns basically. So this setup will allow you to, when it actually builds this, what will happen is it will take the data from the CSV file and it will populate, it will generate insert statements to put that into your table. But as I said previously, the big advantage of this is that when you come to deploy, for example, to a different system, to production, you don't have to remember to go around running some SQL. As you do the deploy, the table will get populated automatically. So it's an integrated part of this delivery of the project. So that's all we need to do. Let's go ahead and run that. So in this case, there's a couple of files. So I'm going to choose DB itself and go for build. That way it will build all of the files that we've just updated. So we can see the build is completed successfully. And if we now go back to look at our tables and we look for the PAL params table and choose open data, now we see we've got those values populated in our table. Isn't that lovely? So we've got the parameters set up. We've got everything basically ready to go to start running this clustering. So how are we going to run it? Well, basically in the project, we're going to have a UI, and on the UI, there's going to be a button saying do the clustering. So you can basically cluster at will. You could also schedule it, which is what we did in a previous iteration of this type of project, Live5. But in this case, we're going to just do on-demand choice of clustering. So to do that, the easiest way is to actually set up a stored procedure, because we're going to need to use SQL script statements to actually make the clustering happen. Now, you've already seen previously with Bob how you can create a stored procedure. In fact, there's one in here called reset. So we've got a reset procedure. So we're also going to create a procedure called cluster. That makes it very easy that we can do reset or cluster from our UI. We just basically get the UI through a web service to call our stored procedure. And we have the business logic encapsulated within our HANA project natively. So to do that, we're going to create a cluster.hdb procedure. So let's go ahead and right mouse button on source, new, and this time a new procedure. We're going to call it cluster in lowercase. If you're following along, do respect the case and the names, otherwise you'll have to change lots of code later when we actually make calls to these things. So here's our cluster HDB procedure. You can see it's set up some basic things. Now, one of the first things we need to do is we need to remove the reads SQL data, because actually this procedure is going to change tables. It's not actually just doing analytics. So we need to make sure that actually is removed. Otherwise it will fail, because it will see we're trying to do actual changes. And then of course we need to paste in some code, or you can write it yourself, but I suspect you're probably preferring that you get the code from us. So if we go and find cluster HDB procedure, you'll see here is the code we need. So just the first few lines, basically up to the 3 dashes. The code that comes later is we're going to modify this in a future video. So let's go ahead and paste that code in. So what have we got in our procedural logic? Well, firstly, we're going to empty out the results and centers tables, the 2 output tables, because each time you run a PAL algorithm, it inserts new rows into the output tables, but it does not delete what's already there. So in our case, we want them to be fully refreshed each time rather than appending. So in this case, we're going to delete before we run the algorithm. Then we're going to actually call our algorithm. You can see on line 14, we're doing our call statement, and there are going to be 4 parameters, P1, P2, P3, P4. So we're going to call our store procedure that we just created a moment ago. We're going to call it, but the first 2 procedures we need to specify. These are basically simple, they're imports. We just need to do a select star from, and then in this case, it's our users view and our parameter table in the PAL context. So these are going to be our 2 inputs. The 2 outputs will come in the form of parameters. It won't write directly into HANA tables, which is slightly different if you just ran this in SQL script in the normal way. So what we need to do is actually have a couple of lines after where we insert into the results and centers output tables the results we get from parameters 3 and 4. So this will be a nice, neat little way that we can actually force the results into the tables we want. Finally, We'd like to know we did the clustering. So you've already seen with Bob in the previous video where we actually have created a set of a tracking table. We can also actually create a row in here basically saying that clustering has happened at this timestamp. So every time we do clustering, that can be logged as well. That could be useful maybe in the future. So let's go ahead and save that. And of course we'd need to build it. So let's build the selected file. And that's now successfully built. Now, there's one other thing we might want to do. If we're doing a system reset, we probably also want to remove what's already in the results tables to clear those out just in case. So what we can do is go to the reset procedure and just add in a couple of lines that actually when we do our reset, we're also going to go ahead and remove the rows that are in the results and centers tables. So let's go there and let's build that one as well. Of course, we could have made both changes and done a whole build on the project. We'd only have to go through the build process once. It's your choice how you want to do that. So that's the reset done. So we're all ready to go. So we can actually go ahead now and start thinking of running the clustering. For that, we just need to call the cluster procedure. So let's go ahead and do that. If we go into the Database Explorer, we've got our procedures. We can see we've got our pal k-means. We've also got our cluster procedure. That's the one that's going to call the pal k-means. So let's go ahead with cluster and actually generate a statement to call it. So let's go ahead. We can generate our call statement. So that's what we need. And then we can just go ahead normally and run it, and it should actually perform the clustering. So it's run, the clustering's done, and we'd want to see our results. So let's go to the tables, and now we should be able to look at the PAL results table. Right mouse button, open data. And what we should see is a row for each user, which has their cluster number amongst some the ID as well. So yep, we can see we've got the user, which is the ID. We've got the cluster number that's been assigned, and we also get a distance column, how far from the center of that cluster mathematically is this user. So that's the basic results. We've also got the centers table, and if we have a quick look at that one, let's open data on the centers table. Here we can see for each of the clusters it created 6. We asked from 5 to 10. It chose that 6 was the best number of discrete clusters based on the data. We can see the center value for stance, influence, and abuse. So it's not easy to put that onto a screen because it's 3-dimensional with stance, influence, and abuse. But these are basically the center values for each of our variables for a given cluster. So cluster 3, for example, has got stance, which the center point seems to be fairly negative. So maybe people not being that positive about our product or whatever it is we're tracking. So that's the tables. Now, if we want to see where we join the data together a bit, we can go to the views. And here we've got our PAL's users clustered view. So if we open that one, we'll see it's basically the results, the cluster number, where we add 1 to the cluster number to make it more readable. So more for a business user. And what we also do is we have added in the information we already had from the users table. So the tweets, the text of the most recent, the stance, influence, and abuse score. And there we can see we've got the cluster number going from 1 to 7 in this case, rather than 0 to 6. And finally, we've got our clusters view, which again, if I open data on that one, we can see here we've got basically the centers of our clusters. We've got clusters from 1 to 7. We've got the stance, influence, and abuse. These are the center values. And also we've got to count the number of users that have been added to each of these clusters. So you can see how many users are in each cluster. And that's going to be useful for us later on in the UI. So now we've finished the approach of creating doing the clustering, the segmentation of our users. We've seen how we've been able to use the different features within XS Advanced. We've used the CDS to create table types in the tables. We've created a store procedure using HDB AFL lang procedure. We populated a CSV file with our parameter initial values using CSV HDB table data. And of course, we created a cluster procedure which allowed us to call it, and we updated the reset procedure just to clear out whenever we do a system reset, clear out whatever we've done with our clustering results. Now, of course, if when we run the clustering, we wanted to maybe change the parameter, maybe the number of clusters or something like that. We can easily do it just by doing an update on our, or an insert or whatever we need to do on our parameter table. Of course, we can do that either in our select or however we want to do that as we're running it. So the fact that we populated the parameters through this CSV doesn't mean the values are fixed forever. It's simply with the initial settings. But of course, in your application, you can come and run, change, customize those at runtime based on how the application is running. So that's the predictive part done. In the next videos, we're going to look at using graph processing to maybe identify for a given Twitter user what their neighborhood is, the users that are not just similar in terms of their values, but also that they've connected people that they've retweeted or have retweeted them, maybe to a number of degrees of separation. So we're going to look at graph processing next. You can find more HANA video tutorials on our YouTube channel. If you'd like to be informed as soon as new video tutorials are published, please subscribe to the channel. You can also connect with us on LinkedIn, follow us on Twitter, and we have pages on Facebook and Google+. Code snippets for all of our tutorials are published to GitHub. Thanks for watching.